Alrighty, so here we go. We're going to do exponential growth and decay applications. You're going to be able to learn how to apply exponential functions to word problems and explain their significance, because hopefully you can show me all sorts of stuff and make me so happy and so proud, and well, we go from there. Anyways, a couple of things here. So this, I'm going to try to keep this simple. You're mainly going to try to show me the functions, and then at the same time try to give me the the specific answer that I might be looking for depending on the word problem. So I'm doing this a little bit differently than what the book asks. Second or next, why is this an orange? Because usually I try to torment y'all with green, because well, why not? Make you hate your school colors. I'm just kidding. Anyways, no, this is an orange because I'm doing this in honor of UT winning their third swim and dive championships in a row. National swim and dive championships in a row. And it wasn't even close. They blew everybody out of the water. It was not even, it's a blowout. So anyways, and this was Coach Eddie Reese's 12th overall championship, making him 13th overall championship, sorry, making him well above anybody else who's ever won that NCAA championships. So, anyways, so here's your secret word for this notes. If you show me before class UT wins, I will give you extra points for the next test. All right, thanks, sounds good, thank you, there we go. So let's move on. All right, so here are your growth and decay formulas for exponential functions, for the applications. Notice here it's a little bit different, but we have an a 1 plus r raised to the t power, or a 1 minus r raised to the t power. The little a stands for initial amount, r is the percent, but it's going to be written as a decimal, and t is time after the initial. So this is something very good to have for your note card. So let's look at the first problem. The first U.S. census was conducted in 1790. At the time, the population was 3,929,214. Really, very specific number. Kind of interesting how they got that. They went one by one. Oh, we counted 3,929,000. Okay, anyways. Since then, the population has grown by approximately 2.03% annually. Find the predicted population for 2020. So based on this, if this had gone the exact same way, everything had been going the exact same way, what would the population of, say, the United States be, say, 3 years from now? All right, so let's see how this gets set up. Okay, so first off, it's a growth function, so it's growing. My A is 3,929,214. My R is 2.03%, which I will change to a decimal, so 0.023203, sorry. And the time is 230 years, because 1790 is the initial time, and 2020 would be 230 years later. So I put all that into the function, and then I would just basically see what do I get as an answer. Okay, and so when you do that, and I just type all this in all at once, and what the calculator gives me initially is that it's saying like this. It'll say 3.99687 which means times 10 to the 8th power. But if you highlight that and then press enter, it will be able to show you the full number. And so that's saying 3,996,86622, and I don't need to worry about anything else because again, this is whole people. We can't have decimals. So if you go based on that, the predicted population of the United States in 2020 is supposedly around 399,686,622 million people. So we're predicting close to 400 million people should be in the world, or should be in the United States at that time. So there you go. Very simple. Notice I could ask you, give me the function and then give me the answer. Next example. Teen spending is expected to grow 3.5. I forgot to put the percent. Oopsie. There's your percent. 3.5% annually from $208.7 billion in 2012. What is the expected teen spending in 2018? So the idea here, again, this is a growth. So let's look at that. So I'm using the growth formula, which again means little a 1 plus r raised to the t power. Okay, so little a is 200. So you have to make sure you understand what is the initial amount that we're talking about. When we're talking about the 287 billion. So you're going to have to keep that in mind, what number that is. Do I want you to type it in as a billion, or do I want you to type it in as 208.7? It depends. I would say right now, I would think you could actually write it as 208.7, but you need to make sure you say billion at the end because hopefully it grows that much. Okay, R, it was 3.5%. So that means that would be 0.035. And then T, okay, if it starts off in 2012, and I'm going to, what did I say, 2018? That's only 6 years. So we're going to go with 6. So we're saying A of 6. So in 6 years, what is that amount? I'm going to put here 208.7. And I'm going to make sure I remember that's billions. So 1 plus 0.035 raised to the 6th power. And again, you could type that straight into the calculator. 208.7. Whoops. 208.7 raised to the 1 plus 0.035 power, or I'm sorry, raised to the 6th power, and then press enter, and you get an answer of that supposedly teens, well, you have spent 256 billion, or $256.546 billion of their parents' money. I didn't say their money because, please. Anyways, I'm kidding. So that's expected teen spending. So, and why is these things type of things important? Well, if you're like a business, you might be looking at this and going, hey, this means we need to start putting in, we actually have to start taking teens seriously as far as spending, and we should have advertising designed to attract them and entice them. I mean, these are very big marketing decisions that can be made. If you're looking at this one, you're looking at, okay, well, 399 million people, we need now to, how do we provide health care for this? How does our Social Security get benefit? You know, there's a lot of decisions that go into these numbers, so it's not just about the numbers. Now let's look at this last example. A cup of green tea contains 35 milligrams of caffeine. The average teen can eliminate 12.5% of the caffeine from their system per hour. How much caffeine is in their system after 3 hours? So you're going to drink this tea. You're going to say this is a eliminate. Notice this word eliminates. That means it's the decay now. I'm going to decay, get rid of, so little a, 1 minus r raised to the t power. So now I'm saying a to the 3 hours, and I'm going to say 35 milligrams. That's how much I have initially. 1 minus the 12.5%, I'm going to change to a decimal, 0.125, and raised to the 3rd power. There's my function, and if I press enter on that, 35 parentheses 1 minus 0.125, close it, raised to the 3rd power, I get 23.4473 grams. Oh, I'm sorry, milligrams. So I'm going to put mg here. So I drank 35, and 3 hours later, there's still 23 milligrams of that caffeine in my system. And that would explain why sometimes some of y'all are getting a little bit crazy and sound a little bit hyper. But there you go. So most of this, I'm not trying to be too hard. Again, I want you to find the function. I want you to be able to find a specific answer, and then maybe be able to say something about that. But there you go. That's it. There you go. Those are the notes for today. Thank you so much for your time. Y'all take care.